Good evening, Lamai. Okay, today we are going to start the discussion about the alkanes, right? So far we have discussed about the nomenclature, right? How to name the compounds. And last day we have discussed about the characteristic reaction kinds of the organic compounds, right? So today onwards, right, we are going to discuss about the kind of organic compounds one by one. Some longer description will be done with these sessions, right? So today our discussion is about the alkanes, right? We are going to discuss about the alkanes today, right? So when discussing a bit about these topics, right? So with each and every compound, we are going to discuss the things under three topics, right? First, we will give you some introduction of the compound, the kind of compound. Then we will discuss about the preparation techniques, how to prepare or how to produce those compounds. Then we will discuss about the reactions of that compound kind, right? So that is how we normally do this discussion, right? First we'll give you some introduction to the compound type, right? Then we'll discuss about the method of preparation, how to produce the compounds, right? Then we'll discuss about the reactions involving, right, the compounds, right? Okay, first let's I'll introduce the alkanes. Actually, we know about the alkanes, right? Alkanes are the hydrocarbons. That means only the carbon hydrogen containing compounds. Only single bonds between the carbon atoms, right? If only single bonds between the carbon atoms are appearing in a hydrocarbon, such compounds are referred to as alkanes, right? That is the simplest idea, right? So these are alkanes. If you need some examples, right? So this is kind of alkane. This is the simplest alkane, methane, right? If you are with the two carbon alkane, it is this ethane, right? These are the alkanes, right? Ethane. See, only single bonds, right? Only a single bonds appearing between the carbon atoms, right? Hydrocarbons, that means only carbon hydrogen containing stuff, and between carbons only single bonds are appearing. Those are alkanes, right? First day we had introduced you the alkanes as well, right? Alkanes. Oh, this one is actually then 1, 2, 3. 3 carbon alkane is named as the propane. 2 carbon alkane is the ethane, and 1 carbon alkane is the methane. Methane, propane. Those are some examples for alkanes, right? So when it comes to alkanes, then as only single bonds are appearing between the carbon atoms as well as the carbon hydrogens, right? So these carbons are actually sp3 hybridized. sp3 hybridized. Only the sp3 hybridized carbons are appearing with alkanes, right? You see, 4 Vesper pairs. So 4 Vesper units. 1, 2, 3, 4. 4 sigma bonds and no lone pairs. 4 Vesper units means sp3. So the carbons in your alkanes are actually sp3 hybridized. sp3 hybridized, right? Those are the alkanes. The hydrocarbons with only one single bonds appearing between the carbon atoms, and all the carbons are sp3 hybridized, right? Such situations are referred to as alkanes, right now. So that is the simplest uh, description about the alkanes. So in your note, you can see the stuff, right? Just go to the note as the first point it is said, right? Okay, right. Then the second point. Next, we are saying this alkane, the series of alkane. So the alkanes are referred to as a homologous series. Alkanes are referred to as a homologous series. Alkanes are a homologous series. Homologous series. Alkanes are referred to as a homologous series, right? Let's discuss what this term means. homologous series, right? Homologous series means a series of compounds, a series of compound, a series of compounds, right? Which are with a common general formula, which are with a common general formula, and the chemical properties are same with a common general formula, and right, same chemical properties, where adjacent members are only differs by a CH2 unit. Adjacent members are only differs by a CH2 unit. Differed by a CH2 unit. Right? So this kind of series is referred to as a homologous series. You see? Right? These are with same chemical properties. Only carbon, hydrogens are appearing. No polar, no positive delta or no more electron deficient carbons. No electron rich carbons. The chemical properties are same with all these things, right? Alkanes. And adjacent members are only differed by a CH2 unit. So if you have to come up with the chemical formulas of these guys, right? This is just CH4. This is 2 carbons and 6 hydrogens, C2H6, and this is 3 carbons and 8 hydrogens. See, you clearly see these two guys differ only by a CH2 unit. If you add some CH2 to this one, you get this thing. Differs by a CH2 unit. If you add some CH2 to this thing, you get the propane, right? Is propane, right? Okay. So adjacent members differ only by a CH2 unit. And then all of these alkanes, right? All of the all of the chemical formulas of these alkanes can be given by a general formula. Like this, right? So you can take the general formula of alkanes as CnH2n plus 2. CnH2n plus 2. This is the general formula of alkanes. H2n plus 2, where n is an integer. Where n is equal to 1, 2, 3, like this. You see? If the n is equal to 1, n means the number of carbons, right? If the n is equal to 1, right, you apply here C1, n is equal to 1. 2 into 1 is 2, 2 plus 2 is 4. That is CH4. If n is equal to 2, C2H, 2 into 2 is 4, plus 2 is 6, C2H6. If C is equal to 3, 2n plus 2 gives you 6 plus 2 is 8. So C3H8. So all of these alkanes, all of the chemical formulas of alkanes, right, are following this general formula, CnH2n plus 2. So it is referred to as an homologous series. The definition of the homologous series is this, Lama. a series of compounds which are with a common general formula. All guys obey this formula. And same chemical properties. They are adjacent members. The nearby members are with only a CH, a difference of a CH unit. Right? These are the this is the definition for the homologous series, and alkanes comes under the homologous series. Right? So you can write this definition, Lamai. Just quickly write this definition with the general formula as well. Write this definition. You have some space in your note, right? So it is said like this, no? All the alkanes can be represented by the general formula CnH2n plus 2, and so alkanes are a homologous series, right? Then some space is there. So just write this thing quickly, right? A series of compounds which are with a common general formula and same chemical properties, where adjacent members are only differs by a CH2 unit. That is what meant by a homologous series. You can highlight the stuff homologous series as well. This is the definition of a homologous series. Right now? Okay, alkanes referred to as a homologous series. Right now? Right. A series of compounds which are with a common general formula and same chemical properties, right? These three things should be there, right? To categorize some compounds under a homologous series. Those should come up with the same general formula like this. Same chemical properties should be shown, right? And the adjacent members should have only a difference of a CH unit, right? Okay. So let's. So you can at the next table you can see, right, the displayed formulas and some blanks are there for structural formula and the molecular formula. Let's fill those things, right, with your table, right, at the bottom of the page, right? So I'll erase this one, right? So let's erase now. Okay. So you have this table, right? Which gives you the displayed formula and the structural formula but I write it here. Displayed formula structural formula and the molecular formula or the chemical formula. One can say the molecular formula, both are same, right? Chemical or the molecular formula. Right? If you take the first alkane, the CH4, it looks like this. For the second alkane, the 2-carbon alkane, looks like this. The 3-carbon alkane. Now a displayed formula means you have to display all the bonds in your compound, right? Such a formula is referred to as a displayed formula. All the bonds in your compound can be seen with that formula. Such a form is referred to as a displayed formula. These are the first four members of alkanes, right? So the structural formula, when it comes to structural formula, right, you are not supposed to display all the bonds. Basically, CH bonds are not displayed, and the CC bonds are not displayed, right? Only special bonds, CH bonds and the CC single bonds are not displayed with the structural formula, right? If some special bonds are appearing, like CO bond, some polar bonds, CC double bonds, CC triple bonds, if such special bonds, electron rich areas and electron deficient things, polar bonds, if those are appearing, those will be displayed. Other than that, the CH bonds and the CC single bonds are not displayed when it comes to structural formula. So let's write the structural formula. So last day we had discussed about how to write the structural formulas, right? So basically when writing structural formulas, first write the carbon and write the hydrogens connected to that carbon at the right hand side of that carbon, right? So this carbon is it 4 hydrogens. So at the right hand side of that carbon, this is the right hand side, just write 4 hydrogens like that. For this one, this was carbon and it is with 3 hydrogens. This with 3 hydrogens, CH3. Then comes the second carbon and that is with 3 hydrogens, CH3, CH3. That is how we are supposed to write the structural formula of this one. If you need to write the structural formula of this thing, this is the first carbon. That guy is with 3 hydrogens, CH3. Then comes to second carbon. That guy is with only 2 hydrogens, CH2. The next carbon, the third carbon, that is with 3 hydrogens. This is the structural formula of 3-carbon alkane, propane. This is the displayed formula. When it comes to displayed formula, all the bonds in your molecule should be displayed. In structural formula, only the polar bonds and the carbon-carbon 5 bonds will be displayed, right? With the structural formula. So this one, 1, 2, 3, 4. 4 carbons are there. With the first carbon, you have 3 hydrogens. The second carbon, only 2 hydrogens. With the third carbon, you have again 2 hydrogens. The fourth carbon coming up with 3 hydrogens. Right? This is the structural formula of the 4-carbon alkane, which is actually butane. Right? Butane. Right? Quickly come up with the chemical formulas as well. Chemical formula is the normal formula. Right? So chemical formula is this thing is just CH4. Here you have 2 carbons and 6 hydrogens, C2H6. Here you have 3 carbons and 8 hydrogens, C3H8. Just the molecular formula. This one, 1, 2, 3, 4. 4 carbons and 10 hydrogens, no? 10 hydrogens. That simply giving you the molar ratio between the constituent atoms. Simply displaying the molar ratio between the constituent atoms. That is the molecular formula or the chemical formula of a compound. That is actually known from your small ages, the molecular formula or the chemical formula, that concept. Just displaying the actual number of moles of constituent atoms in your compound, right? So that is the chemical or the molecular formula. So this is the structural formula, right? And displayed formula means all the bonds are displayed, right? So just complete the stuff with your table, right? Which is at the bottom of page number 11, right? So with this as well, you can clearly see that requirement that between two members, so only a difference of CH2 should be there. That requirement is fulfilled. See, between these two guys, only a difference of CH2 unit is there. If you add some CH2 unit, you will come up with this. Between these two guys, again a difference of CH2 unit is there. If you add some CH2, to this one, you get this C3H8. Between these two guys as well, just a difference of CH20 is there. So alkanes comes under a homologous series, right? All the guys following the same general formula, CnH2n plus 2, right? No? So just come to the table now, right? Simple stuff, right? Not that much hard stuff here. This is just the introduction of alkanes. This is all about the introduction of alkanes, right? As alkanes are not with electron deficient carbons or electron rich areas, alkanes are referred to as normally less reactive species. The nucleophiles won't attract towards the alkanes, electrophiles won't attract toward the alkanes, right? So these are normally referred to as less reactive species, right? Alkanes. Okay, that is what mentioned at the last point, right? As alkanes do not contain 5 bonds, right? It says or functional groups or positive carbons, right? The reactivity of alkanes are very low compared to the other organic compounds, right? That is what it says, right? It's all about alkanes. හරනේ ළමයි මේක කම්ප්ලීට් කරගන්න පුළුවන්. Just take a screen capture, then we can proceed to the next page. This is all about the introduction for the alkenes, right? Then let's talk about the reactions. Sorry, before the reactions, let's talk about how the alkanes are produced. How we are supposed to produce alkanes. Let's discuss about that. After that, we can go for the reactions, right? Okay. So production of alkanes, the next topic. Right. So production of alkanes. There are 4 methods. There are 4 methods discussed in our A-level syllabus to produce alkanes. 4 methods are discussed, right? 4 methods are discussed, right? Sorry, for alkanes, no? 4 methods are discussed. The first method, right? So you can come up with a catalytic hydrogenation of alkenes, right? If you are to hydrogenate alkenes, right? You can come up with alkanes like this. This is referred to as catalytic hydrogenation of alkenes, catalytic hydrogenation of alkenes, right? So it's like this, see, right? This is kind of a alkene, right? Right, like this. It's kind of alkene, right? Just alkene. Right? So if you can replace this bond, this 5 bond with 2 hydrogens, if you get rid of this 5 bond and replace it by 2 hydrogens like this, CH3 still appear. Instead of this 5 bond, if you can put 2 hydrogens like this, so it is going to be a alkane, right? This is kind of a alkene, and this is a alkane. So you can convert the alkenes to alkanes by performing a catalytic hydrogenation. That means the hydrogen should be added with a D block catalyst. D block catalyst. So you can use for this purpose, right? The H2 with nickel catalyst or H2 with palladium catalyst or H2 with platinum catalyst. Right? Those are the three available catalysts in our syllabus, right? So if you are at H2 nickel or H2 palladium or H2 platinum to an alkene, then you can convert the alkene to a alkane, right? What you are doing is just removing the phi bond between the two carbons and connecting two hydrogens instead of that phi bond. If you remove this phi bond, right, as carbon should have 4 bonds around it, right? So if you remove this phi bond for both of the carbons, there should be some bonds, right? So two hydrogens will be connected instead of the phi bond, right? So just write this one, Lama, at the space given, catalytic hydrogen of alkenes, right? That is the first method of producing alkenes, right? Okay, catalytic hydrogen of alkenes. So messages are there. Okay. Right. That is the first method. Just complete that thing, this thing, man. Right? Next method. You can do the same for the alkynes as well. Alkynes as well. Catalytic hydrogenation of alkynes. Alkynes, you know about the alkynes. Alkynes are the hydrocarbons where you see triple bonds between carbon atoms. Alkynes. So you can do such a thing as well. See, if some alkyne is like this, right? Some alkyne, and you can take some alkyne like this, right? If you can replace these two phi bonds of your alkynes by hydrogens, by carbon hydrogen bonds, then what will happen? Then that thing will look like this, no? Right? Instead of one phi bond, two hydrogens will be added. Instead of the second phi bond, another two hydrogens will be added. So altogether, 4 hydrogens will connect to those two reactive carbons. Here, instead of one phi bond, 2 hydrogens will be added, right? So here, as you are with 2 phi bonds, 4 hydrogens will be added, right? So again, you had produced kind of a alkyne starting from a, sorry, you have produced an alkane starting from an alkyne, right? The same reagents can be used to do the hydrogenation, to add the hydrogens, H2 nickel, H2 palladium, or H2 platinum. Any one of those three can be used to do this process. Right? There is a second method of producing alkenes. So by alkenes as well as alkynes, you can produce the alkenes by just adding hydrogens, right, instead of the carbon-carbon 5 bonds. For that, what we need to come up is with actually catalytic, D block catalyst should be there with H2, right? Just complete this thing as well now. For any alkyne, this is valid, not only for the 4 carbon alkyne, for any alkyne, if you are to add this reagent H2 nickel, H2 PD or H2 platinum, you will come up with the corresponding alkane, right? Okay, so just write that thing as well now. These are two simplest ways to produce the alkanes, just performing some catalytic hydrogenation. Right. Let's discuss about the third method of producing alkanes. The third method. Right? Okay, I'll erase this thing. The third method is you can perform a reaction called Clemmensen reduction. Clemmensen reduction. Clemmensen reduction. Clemmensen reduction on aldehydes or ketones. Clemmensen reduction on aldehydes or ketones, right? That will also produce alkanes. See? So this is kind of a, sorry, I'll write it in blue, right? This is kind of a aldehyde. And you can come up with ketones as well. Ketones as well, right? So aldehyde is a ketone. You can identify these things, no? Aldehydes to the C double bond O section, R group and a hydrogen is connected. To a C double bond O section, two R groups are connected, the ketones, right? So to these, right? If you are to add this reagent, right? Zinc amalgam with conc HCl. Zinc amalgam with conc HCl. If you add this reagent, what will happen? This one, right? This section, the C double bond O, this section will convert to a CH2 section like this. The CH3 is still there. This thing is there. What will happen? This double bonded oxygen will release, and instead of that, two hydrogens will connect to that carbon. See, for this thing as well. Double bonded oxygen releases and two hydrogens will be connected. So you see, those are alkanes. CH3, CH3, or in this case, CH3, CH2, CH3, CH3, CH2, CH3, right? So one can write like this now. This is actually CH3, CH2. That's all. No? CH3, CH3, sorry. And this one is actually CH3, CH2, CH3. Right? Those are alkanes. Those are alkanes. Corresponding alkane. So aldehydes and ketones can be reduced to produce alkanes. You clearly see here, the carbon-oxygen bonds are releasing, right? You decrease the number of carbon-oxygen bonds, it's a reduction. You increase the number of carbon-hydrogen bonds. Going from here to here, increase the number of carbon-hydrogen bonds, reduction. Decrease the number of carbon-oxygen bonds, reduction. So these reactions are referred to as Clemmenson reductions. This is the reagent known as the Clemmenson reagent. Zinc amalgam with concentrated HCl. Right? With this method as well, we can produce the alkanes. The third method, which can be used to produce the alkanes. For any aldehyde or any ketone, can be reduced like this to come up with alkanes. Instead of this carbon-oxygen bond, you come up with two carbon-hydrogen bonds. Right? Removing oxygens, reduction. Adding hydrogens, reduction. That is what happens here. Right now. Okay, just complete this stuff now quickly. At the space given. The third thing, Clemmenson reduction on aldehydes and ketones. This is the third method we can use, right, to produce the alkanes. Right. Let's come up with the fourth method, the fourth one. So here what we have done is actually just removing the carbon-oxygen stuff, right, and just added two hydrogens instead of that, right? So because altogether 4 bonds should be there with the carbons, no? Octet role should be fulfilled, no? So 4 bonds there should be 4 bonds around the carbon. No? So if you have to remove 2 bonds, you have to just add another 2 bonds as well, right? That is why 2 hydrogen bonds added, right? It's a reduction to come up as an alkane, right? Okay, let's write the fourth method. Let's come up with the fourth method. ළඟ ඔයගොල්ලෝ සාමාන්‍යයෙන් මේ ලියන්න පටන් ගන්න කලින් පොඩ්ඩක් අර ස්ක්‍රීන් කැප්චර් එකක් පුළුවන් නම් දාගෙන ස්ක්‍රීන් කැප්චර් එකක් දාගෙන ලියන්න පටන් ගන්න. එතකොට ඔයාලට මේ වොරි වෙන්න දෙයක් නැහැ. නෝට් එක මතක තියෙනවනේ ලියන්න පුළුවන් පස්සේ හරි. හරිද? නැත්නම් හයියෙන් ලියන්න ගිහලා ඒක කත වෙන්න පුළුවන් නෝට් එක හරි ඊට වඩා ලේසි. ටක් ගාලා ස්ක්‍රීන් කැප්චර් එකක් දාගෙන ඊට පස්සේ ලියන්න පටන් ගත්තා නම් කොහොමද ප්‍රශ්නයක් නැහැ. හරිද? Right. Next, the fourth stuff. Fourth kind of reaction. හතරවෙනි කේස් එක. දැන් ඔය හතරවෙනි කේස් එක නම් අපි විතර වැඩිපුර කතා කරන්න යන්නේ නැහැ. Right? That reaction will be discussed more with the Grignard reagent stuff. Right? With our tute number 3, we will discuss more about this reaction, but I'll simply write the reaction. The fourth method of producing alkanes is actually reacting the Grignard reagent with organic compounds with or any compound with positive polar hydrogens, right? Reaction of Grignard reagent. With compounds containing positive polar hydrogens. That is the fourth method. Right. First of all, I'll introduce you what is the Grignard reagent. Grignard reagent is actually a reagent like this. Grignard is this, right? Grignard reagent means is kind of a compound like this. So you have a right MGBR section. You have a MGBR section connected to R group. Connected to R group, alkyl group, you have a MgBr section. This is what referred to as the Grignard region. Grignard region. So if to R group, if Br is connected, it's a alkyl halide. To R group, if OH is connected, it is alcohol. Like that, no? If to R group, some MgBr section is connected, it is a Grignard region. It's a Grignard region, like this. See? This is a Grignard region. CH3, CH2, like this, I'll just write. CH3, CH2. This is R group, no? If you are to put some hydrogen here, it's an alkane. This is alkane. If you release that hydrogen, this is R group. To this R group, if MgBr is connected, MgBr section is connected, this is referred to as a Grignard region. We'll discuss more about this Grignard region, right, with our tute number 3, right? Even with the tute number 2, right? Not here, right? So, if you add some compound containing positive polar hydrogens, like water, few compounds are written here, right? Even the ammonia, even the alcohols, right? Ammonia, any kind of stuff, right? Compound is positive polar hydrogens. I'll write few, right? Carboxy acids, right? When we are referring to these hydrogens, these are positive polar hydrogens, huh? Because of the OH polarity, these are positive polar hydrogens. Even with the NH polarity, you create some positive polar hydrogens, right? As the oxygens are more negative than hydrogens, the electron pair will be attracted towards the oxygen, creating some greater polarity on hydrogen, right? Those are the positive polar hydrogens, right? If you add one of these, or even the compounds with NH, positive polar hydrogens, to your Grignard region, what will happen? It's kind of this. Lamai, when it comes to this bond, CMG bond, magnesium is with 1.2 electron, the carbon is with 2.5 electron, so your carbon is negative here. Your carbon is negative delta. This is positive delta. So what will happen? So this negative delta carbon will connect with this positive delta hydrogen. This is what happens. This negative delta carbon, right, comes and connect with this positive delta hydrogen, releasing this MgBr. This carbon releases this MgBr and connect with this positive delta hydrogen. This MgBr will go with the other section of this. That is what happens. These two will get connected, releasing the MgBr. So that what will happen? Instead of MgBr, some hydrogen comes here. Instead of MgBr, some hydrogen comes here. Instead of MgBr, some hydrogen comes here. I write it here. Right? This hydrogen will come here. Right? Come to this section to connect to this high carbon. Right? So that ultimately you will produce some alkane. Ultimately you will produce some alkane like this. So with this reaction also, kind of alkanes are produced. MgBr will leave. We are just concentrating on the organic stuff, right? So this is another method of producing alkanes, but practically this won't be done. Right? Because Grignard regions are more important stuff, more valued stuff than the alkanes. So that we are not using these expensive stuff to create cheap ones. Right? These are expensive stuff and hard to make. So we are not supposed to use those things to create some cheap ones. right? So that normally is not done practically, but there are reactions like this. If a greenhouse reagent is there in a solution with positive polar hydrogens, then these kind of reactions will occur and ultimately produce some cheap alkenes, right? So that is that reaction, right? So that is the fourth way of producing alkenes according to our syllabus. Only those four are available, right? Okay, no? So as positive polar hydrogen, compounds containing positive polar hydrogens, not only the OH polarity, NH polarity also can be used even with ammonia, RNH2s, right? Still you can produce those things, those alkenes, right now? Okay. Okay, this is all about production of alkenes, right? You can use alkenes and alkynes and get rid of the 5 bonds there, and you can add some hydrogens to those alkenes and alkynes so that alkanes will produce. The second method is actually third method is actually performing the Clemmensen reduction, right? So that you can get rid of the carbon oxygen double bond and copy 2 hydrogens there, so that alkanes will be produced by aldehydes and ketones, right? So those are the 3 methods available to produce the alkenes, right? Any other question? තව මොනවාට ප්‍රශ්න තියෙනවද ඔයාලට? නෑ නේ. හරි. එහෙනම් අපි යමුද ඊළඟ කේස් එකට. Right? So we'll discuss the next stuff. That is about the reactions of alkenes. Reactions of alkenes. Reactions of alkenes, right? That is our next discussion, right? Reactions of alkenes. Right. Normally, alkanes are considered as less reactive species. At the beginning of the lesson today, I have mentioned that, right? Normally, alkanes are considered as less reactive species. The main reason is actually alkanes are not with positive polar carbons. Alkanes are not with positive polar carbons because no electronic difference, much of electronic difference appears with the atoms of alkanes. So no positive polar carbons in your alkanes, so that nucleophiles won't attract or attack towards alkanes. And alkanes are not with electron-rich areas as well. Alkanes are not with electron-rich areas as well. So no electrophiles will attract or attack towards alkanes. So not that much of a reactivity with alkanes, right? So no electrophilic reactions, no nucleophilic reactions with alkanes, right? But there are 2 kinds of reactions. One is actually you can perform some combustion with alkanes. So with hydrocarbons, if you are to combust hydrocarbons, right, you will produce the CO2 and H2O. That is what happens now. You know the stuff now. Basically, the fuel, right? Fuels are actually hydrocarbons now. Petrol, the methane. So the petroleums, all things are hydrocarbons now. So you can perform kind of a combustion reaction to come up with CO2 and H2O. That is one kind of reaction available with alkanes. That is not much discussed with the organic chemistry, right? Such things are basically discussed with the inorganic as well. No, the inorganic compounds are produced, no, H2O and CO2 by the combustion of alkanes, right? So H2 and CO2 are inorganic compounds. So not any kind of an interested organic compound is produced. So that is not considered as an organic reaction, right? So that reaction with alkanes is referred to as kind of an inorganic reaction, producing some inorganic compounds. So we are not going to discuss about that reaction further, right? So our main consideration is this next reaction kind, right? That is referred to as the free radical substitution reactions. So no electrophilic reactions, no nucleophilic reactions, but a new kind of reactions referred to as free radical reactions, free radical substitution reactions. So I'll explain that thing a bit more, right? Because only one or two, only two free radical reactions are available in our A-level syllabus. Not that much, right? Very few free radical reactions. Actually, two free radical reactions are available in our syllabus, right? So one is this free radical substitution reaction, right? So that is the major reaction kind we discuss with the alkanes. So what is that? It is the free radical substitution reactions, right? Free radical substitution reactions. Okay, so that is the only reaction kind we are going to discuss with the alkanes, right? So first of all, before discussing about this reaction kind, first let's discuss about what are these free radicals. What are these free radicals? You know about the substitutions. What means by a substitution reaction? You know, instead of a species, you are to add a newcomer by replacing kind of existing. That is a substitution, no? Right. So let's discuss about what are these free radicals. What are these free radicals? Right. It is like this, Lamai. So if you are to think of a bond, if you are to think of a covalent bond, see, if you are to think of a covalent bond, right? Let's say some covalent bonds, right? So like this, there are two kinds of covalent bonds now. One kind is this, right? One kind is that. This is another kind. Two kind of covalent bonds, right? This is referred to as a non-polar covalent bond, where the electron difference between the two atoms are not that much. Here the difference is 0, and here the situation is bit different, right? This is referred to as a covalent bond with very less difference in neutrality. So electron difference is less, such situation, or electron difference is high. There are two kinds of covalent bonds. These are normally considered as polar covalent bonds. These are non-polar or almost non-polar. Covalent bonds. If the electron difference is very less, like in CH4, those comes under this category. Yeah, those comes under this category. Almost non-polar. In alkanes, the bonds are almost non-polar. Huh? These are the two kinds of covalent bonds normally, according to polarity. So when a reaction is to occur, right, what happens is basically the bonds in your reactants will break and new bonds will form. That is what a reaction means, right? A reaction means bonds in your reactants will break and new bonds of the products will form. That is what a reaction means, right? So to undergo a reaction, definitely bond breakings should occur. Without bond breakages or without bond breakings, you can't think of a reaction. You can't discuss of a reaction. So basically, the bond breakings, when it comes to bond breakings, there are two types of bond breakings available. There are two types of covalent bond breakings are available. One kind is actually when both the electrons in a covalent bond, when both the electrons in a covalent bond, right, like this, you have two electrons in a covalent bond. So when both the electrons in a covalent bond goes towards the more electronegative atom, when both the electrons in a covalent bond goes towards the more electronegative atom, right, that is one kind of bond breaking, which will ultimately produce the ions, when both the electrons going towards the chlorine. Now the hydrogen's electron also coming towards the chlorine, so chlorine gets a minus charge. As hydrogen loses its electron, it gets a positive charge. This kind of a bond breaking will lead you to ions. Right? This is one type of bond breaking. The other type of bond breaking available is the two electrons in a bond can, right, go towards two atoms, one each, like this. One electron go towards this atom, the other electron goes to the other atom. When the two atoms are with the same electricity values or considerably similar electricity values, both the atoms are keen of electrons, so that one electron goes towards this atom, the other electron goes to the other atom. Right? When such a bond breaking occurs, we create this kind of species. Two chlorines with one single bond, one single electron on it. This situation is referred to as free radicals. Free radicals. These are radicals. Radicals. Free radicals. That is how the free radicals are produced. This is how the electrophiles, nucleophiles produce. This is a -1, which can attack to a positive carbon, a nucleophile. This is a +1, which can attack to an electron-rich area of the carbon, electrophile. This is how the electrophiles, nucleophiles produce. By this kind of a bond rupture, you will come up with free radicals. When electrons going towards the two atoms, one each to two atoms, right? So in such a case, you will produce the free radicals. So alkanes will participate in reactions with free radicals, not with electrophiles or nucleophiles. With these guys, alkanes will react. Actually, these free radicals are also very reactive, as like in like ions, the electrophiles, nucleophiles, the free radicals are also very reactive. Why is that? Because when it comes to free radicals, their valence shells are not completed. When it comes to free radicals, their valence shells are not completed. Odd number of electron count means you are only with 7 electrons with the chlorines, right? The octet is not completed, right? It is not like Cl2. It's just Cl dot. Cl dot means just Cl, the atom Cl, not with any charge, right? Just Cl atom. So you have the other pairs there, just chlorine. Means octet is not fulfilled. So those are very reactive, right? So try to come up with octet by combining with another atom. So free radicals are very reactive, as well as the ions, right? So with the free radicals only, the carbons of the alkanes will react, right? Alkanes are not participating with the reactions with the nucleophiles and electrophiles, right? But with free radicals, they will react. So the reaction kind is referred to as free radical substitutions, right? So we'll discuss how this occurs. Before that, let's have a quick note about this thing. Let's have a quick note about this thing. අපි පොඩ්ඩක් මේ ගැන පොඩි නෝට් එකක් දාගමුද? මෙහෙම ලියන්න එපා. ඔයාලගේ ටියුබ් එකේ හරි cover page එකේ ඔය front page එකේ මෙන්න මේ පොඩි මේ නෝට් එක දාගන්නකො. මම මේ idea කොට දෙන්න. ලස්සන. මොකද මේක මේ general idea එකක් නේ. මේක මේ ඕන තරම් use වෙන general idea එකක්. හරි මේක ඔයාගේ මේ notebook එකේ පළවෙනි පිටේ ලියා ගන්නකො. පළවෙනි පිටේ හරි අන්තිම පිටේ හරි ගවන්න කොහෙද බලන්න පුළුවන් තැනක ලියා ගන්න. මේක මේ මුළු organic chemistry හැම කතාවටම දාලා දෙයක් නේ. It's just a fundamental thing you should know, right? මෙන්න මේ ලියා ගන්නකො. හරි පොඩ්ඩක් මෙන්න මේ note එක දාගන්නකො. හරි there are මාත් එක්ක ලියන්නම. there are two kinds of bond breaking. There are two kinds of bond breaking in organic chemistry. There are two kinds of bond breaking in organic chemistry. හරිද? මේ note එකට දාගන්නකො. first page එකේ හරි last page එකේ කොහෙද තැනක. sticky note එකක් විදිහට දාගන්නකො. හරි. First type is referred to as, right, homolytic or homolytic cleavage. Homolytic cleavage. අර අපි කියු පළවෙනි type එක. ඒ පළවෙනි type එක තමයි මේ උදාහරණයක් ඕන්න. When the atoms are with more or less the similar electronicities, right? One electron goes towards one atom, the other goes towards the other atom. Here, the electronic movements are denoted by arrows. Here, the electronic movements are denoted by arrows, right? For a one electron movement, we are using a half arrow. For a one electron movement, we are using a half arrow. Homolytic cleavage එකෙන් දාන්නේ half arrow එක. Half arrow මේ half මේ මිතුරු half එක නෑ මේ පැත්තේ half එක නෑ. Just one half of the arrow. Half arrow. Divided by half arrows, right? Half curvy arrow. This is denoted by a half curvy arrow. Homolytic cleavage. Arrows are actually indicating the electronic movements. One electron from here coming towards the chlorine, this chlorine, the other electron coming towards this chlorine. One electronic movement will be denoted by half arrow. So after this thing happened, you will see this electron coming towards this and the other electron coming towards the other thing, right? So with this kind of homolytic cleavage, you will come up with free radicals. It will produce free radicals. Right now? Free radicals. Two free radicals. No? Just draw this one. A second kind happens when you have a considerable electron difference between the two atoms. When you have considerable electron difference between two atoms, right? It is referred to as the heterolytic cleavage. There both the arrows will go towards the more electronegative atom. Like this. both the electrons will go towards the more electronic atom. Here, the movement of two electrons will be denoted by a complete arrow, denoted by a complete curvy arrow, right? तो આપણે arrows දෙකක් use කරනවා. arrows කියලා කියන්නේ මොනවද? arrows කියලා කියන්නේ electronic movements. electrons දෙකක් move වෙනවා නම් complete arrow. electron එකක් නම් move වෙන්නේ half arrow. So heterohomogeneous cleavages will be denoted by half arrows, and heterogeneous cleavages will be denoted by complete arrows. With that, you will produce ions. හරි අර ආපු ඉලෙක්ට්‍රෝන්ස් දෙක ළම අපි සාමාන්‍යයෙන් මේ මයිනස් එකේ උඩින් දෙනවා මේ ඔහොම දානවා. ඕනික් වල සාමාන්‍යයෙන් හිමද කරන්නේ. හරි. අර මෙතනදී ඉලෙක්ට්‍රෝන්ස් දෙකම ආවනේ CL ගේ උඩට. So we denote like this. That is how the organic things are written. The electrons okay will be written on that atom. So here both the electrons came towards the chlorine, so that is denoted like this. Even hydrogen loses its electron, that is why hydrogen gets a positive charge. Chlorine gets the hydrogen's electron, that is why chlorine gets a negative charge. Right now, the heterolytic cleavages will produce normally ions. Positive and negative ions. Right now, ඉතින් පොඩ්ඩක් ළමයි මෙන්න මේක පොඩ්ඩක් ඔහම ඇඳ ගන්නවද? ලියා ගන්නවද? Right. This is very important නා. මෙතන ඉස්සරහට අපි කතාවට මාර වැදගත් මේ කතාව. අද ඉඳන් ඉස්සරහට හැම ලෙසන් එකකටම මොකක් වැදගත්, right? There are only two methods available to break the bonds. හරි ඔය තමයි ඔයාගේ කතාව. Right. With this knowledge, let's discuss the free radical substitution reaction of alkanes. Knowledge එකත් එක්ක අපි ඒ විදිහට යමු. So alkanes ලගේ මේ reaction type කියන්නේ මේකින් හොඳයි. It's a free radical substitution. Right? Alkanes are not involving with these guys. Electrophiles, nucleophiles won't attract towards the alkanes because alkanes are not with electron deficient carbons or electron rich areas. So as electron deficient things are not there, these guys are not attracting there, or these ones, right? But the free radicals can attack, right? Okay, let's discuss the reaction kind, the characteristic reaction kind of alkanes, the free radical substitution, right? මේ arrows වල කතාවයි තමයි මාර වැදගත් උනේ. So arrow එකක් කියලා කියන්නේ electronic movement එකක්. හොඳට ඔලුවට ගන්න එක. curve arrow එකක් කියලා කියන්නේ electronic movement එකක්. හරි? It will be important නා. අපි ඊට පස්සේ කතාවදී තේරුම් ගන්න. electrons තියෙන තැන ඉඳන් එතනට යන්න, right? හරි. අපි කතා කරමු ඉස්සරහට, right? එතකොට half arrow එකක් කියලා කියන්නේ one electron movement එකක්. complete arrow එකක් කියලා කියන්නේ two electron movement එකක්, right? ඒක උඩ ඔලුවේ තියාගන්න. We'll use those things, right? Okay, so let's discuss about the free radical substitution thing, right? Hard. So I'll come up with some examples, right? So these are some examples for free radical substitutions of alkanes. So this is CH4, right? CH4. By adding, right, Cl2 in the presence of sunlight. By adding Cl2 in the presence of sunlight, you can substitute chlorines instead of these hydrogens. Instead of these hydrogens, you can substitute the chlorines, right? like this. You can substitute 1 chlorine, even 2. By adding excess of Cl2, you can go for more chlorines. Up to 4 chlorines, you can do so. You can substitute all the hydrogens with chlorines. This is referred to as the substitution reaction. Occurs with alkenes. Right? By adding required amount of Cl2, you can do so. Right? Even you can do the same kind of a reaction with Br2 as well in the presence of sunlight. In the presence of sunlight with Br2 as well, you can carry out same kind of a reaction, substitution reaction. Instead of the hydrogens, you can substitute Brs. Not only with the 1 carbon alkane, the methane, but also with the 2 carbon, 3 carbon, any alkane. Right? You can do this free radical substitution reaction. Brs will be the ones to substitute if you are to add Br2H mu. Right? Even all the hydrogens can be substituted. Right? So this is the free radical substitution reaction with alkenes. Not only with the methane, but also with any kind of alkane. Ethane, propane, butane, all the alkenes can be used to come up with these chlorinated or brominated products with Cl2H mu or Br2H mu. Right? So this H mu means sunlight. Normally, the UV rays in your sunlight will be used here. UV rays of your sunlight will be used here. Right? Just write these two now. Space see, it is there, right? Free radical substitution of chlorine, bromine to alkenes, right? In the presence of ultraviolet light, X2, the Cl2 or Br2, reacts with methane to give a mixture of haloalkenes. Mixture of haloalkenes. Alkyl halides, no? Right? So you can come up with these things, right? So methane is used in this case. You can use any kind of alkene, right? Just write these two at the space given. Right. Actually, not only these aliphatic chains, but this one, this aromatic compound, right, which is known as the toluene, The aromatic compound is known as toluene, right? Okay, so you can write this thing or like this. So anyway, toluene, right? The hydrogens in the toluene here also can be substituted with halogens, right? With halogens. If you add Cl2H mu here, so this will also produce CH3 instead of one hydrogen, sorry, CH2 instead of one hydrogen, one chlorine will attach. Or you can come up with CHCl2, two chlorines connected instead of two hydrogens. Or you can come up with CCl3 as well. So not only with the aliphatic chains, but also with the aromatic chains. Aromatic, right? Hydrocarbon chain, I mean alkane sections. With aromatic compounds even, if you are with some alkane section there, with aromatics, with some alkane section there, those hydrogens can be also substituted by chlorines using the same technique, right? This compound is referred to as toluene. This compound is referred to as toluene, right? That is also there in your note, right? That thing also can be done. Not only the aliphatic alkanes, if you are with aromatic compounds with some alkane sections, those hydrogens can be also substituted using the chlorines, right? So this is the only reaction type available with the alkanes, right? With some organic interest, right? Okay, now you can write this one as well. This is given, no? So you can complete now, right? So we have a question, right? Yes, let's see. What affects how many hydrogen groups in a hydrocarbon are substituted by an X group? Yeah. So question is asked. Your friend is asking which will decide the number of halogens going to connect with the organic compound. Actually, that will be decided by the amount of reagent you are going to add. Amount of reagent you are going to add. If you are adding excess of Cl2, very high amount of Cl2 compared to the organic molecule, molecule. If you are adding a high amount of reagent Cl2, then most probably you will end up with CCl4. If you are adding very small amount of Cl2 with high amount of methane, you will get, right, a reaction mixture more with the CH3Cl. Always reaction mixture will form, but according to the amount of reagent you are adding, the major and the minor products will be decided. Right? So if you are adding more chlorine, a very excess of chlorine compared to the organic compound, then major product would be the CCl4. If you are adding very less amount of chlorine, very limited amount of chlorine compared to the methane, major product will be this one. So according to ratios you are adding, you can come up with the CH2Cl2 as well as CHCl3. Is it okay, Mishra? Right, no? It will be decided by the amount of this thing you are supposed to add, right? So in an exam point of view, right, by adding this thing, if you write this answer, any answer, all will get marks. If the question is given as this one and this thing only, not indicating the amounts of the reagents adding, then any answer will be considered as correct. Right? Okay. Right. So this is the only reaction involved in the alkanes. Right. Then let's discuss about the mechanism of this thing. Mechanism of producing these products. mechanism of producing these products from the starting compound. This is the starting compound, this is the reagent, this is the product. So let's discuss about the mechanism of producing the products from the starting compound. Right? Mechanism. What this means? A new word, mechanism. Let's discuss about that thing as well. Few new words are there, right? Coming here and there. This is a new section, organic chemistry, right? So, mechanism. Let's discuss about that thing as well. What this means. Now we are supposed to copy the mechanism of the reaction. No? So, free radical substitution, right? So let's write this thing. Free radical substitution reactions, right? So let's write this one. This is our reaction. CH4 reacting with Cl2H mu. This is our reaction, right? To produce the CCl4. This is our reaction. Only the organic product is enough, right? When writing the products of a reaction, only the organic product is enough, right? No need of writing the hydrogen containing stuff and stuff, right? For the reaction, when writing a reaction, if they have asked you the reaction, just write in the organic thing is enough, right? So now my focus is to copy the mechanism of this reaction. Mechanism. So in organic reactions, we need to copy the mechanisms. Right? There is section mechanisms. At the first day I have, when we are discussing about the sections, right, 50 marks will be allocated for mechanisms out of 250 marks, right, in your written paper. Okay, this is what this mechanism means, right? It is this. Mechanism means kind of representation, right? Kind of a representation, right, of all the bond breakings and bond formings, right, of your reaction. So at the start I have said that when a reaction occurs, the bonds of the reactants will break and the bonds of the products will form, no? So mechanism is kind of a representation of all those bond breakings and bond formings in your reaction. Right? All the bond breakings and bond formings of your reaction will be represented by a mechanism. Representation of all the bond formings and bond breakings in your reaction is referred to as a mechanism. Right? When you are writing a mechanism, right, actually when happening bond formings and when happening the bond breakings as well as bond formings, those things will happen due to the electronic transitions. Due to the electronic transitions, a bond will break because the two electrons in that space go towards one atom, or the two electrons go towards the two atoms, one each to both the atoms. Like that, no? That is the only two ways of breaking the bonds, no? So bond breakings happen due to the electronic movements. Bond formings as well as bond formings will happen due to the electronic movements. So in mechanisms, the bond formings and bond breakings will be denoted with curvy arrows, which represents the electronic movements occur when happen in the bond breaking and bond forming. Right? So that we can summarize the idea like this. A mechanism is kind of a representation which indicates the bond formings and bond breakings with the use of curvy arrows that happens in a reaction. Right? That is the simple idea of mechanism. So let's try to come up with the mechanism of this reaction. In A levels, they will ask you to write the mechanism of a given reaction. So now we are going to study the mechanism of this reaction. Mechanism of this reaction. Right? Let's write the mechanism. When it comes to this reaction line, when it comes to this reaction, right? This mechanism contains three major steps. Three major steps. The first step is referred to as the initiation stage. Right? Initiation step or the initiation stage. The second part is referred to as the propagation step. Ultimately, the termination step. The total mechanism of this reaction comes with these three sections. One by one, let's study the mechanism. First, starting with the initiation step. Right? I'll write it here. Right? The mechanism, I'll write it here. Right? Mechanism. Right? The first thing is initiation step. Now all things start with this. All things start with this step. First, the Cl2 will break its bond like this. One electron coming towards this chlorine, the other electron coming towards this chlorine. One electron movements, so that half arrows should be used. Half arrows should be used. So this will produce 2 of Cl dots, 2 of chlorine radicals. Cl dot from this electronic movement and another Cl dot from this electronic movement. 2 of Cl dots. This is referred to as the initiation step of this reaction. Is the initiation step of this reaction, right? Okay. Then, after the initiation step, propagation steps comes. Propagation steps. Propagation steps, not just steps. Propagation steps, right? And final steps, right? Propagation steps. Right. Let's try the propagation steps of this mechanism of producing CCl4 starting from the CH4. Right. Propagation steps. It happens like this, Lama. So you have this CH4. You have this CH4. That's right. You have this CH4. And so produce Cl dot T here now. Right? CH4 is here. Cl dot T here. So first what happens is, right? Just highlight like this. Try to write this bond very clearly. What happens is, actually, this bond will break. Definitely, you need to come up with 4 of chlorines, no, instead of hydrogens. So that you have to release these hydrogens. You have to release these hydrogens and connect some chlorines. So what will happen here is, first, this bond will rupture. This bond will break by giving one electron to this carbon and the other electron to this position. Right? And then this electron will also come to this section to produce this one. H, C, H, H, and a dot, because this electron came towards the carbon, this dot, and one electron of this hydrogen and one electron of chlorine coming towards here to form the HCl bond. Right now, that is what happens by this kind of electronic movement. This is the first thing happen as the propagation step. Now we are trying to come up with new CCl bonds instead of CH bonds. First of all, we have to get rid of CH bonds. One CH bond, and then we can connect an CCl bond. Then what happens is, to this one, to so produce carbon dot, carbon radical, to so produce carbon radical, then a Cl2 molecule will attack, or this carbon radical will attack to a Cl2 molecule. Not only one Cl2 molecule is there in your reaction vessel, right? Avogadro's amount of Cl2 molecules are there in your reaction vessel, right? Okay. When one Cl2 molecule breaks like this, some other Cl2 molecules are there without the rupture, right? So produced radical will attack to a Cl2 molecule. A reaction between a radical and a Cl2 occurs, right? So that it will ultimately create this kind of a thing will happen. So this bond will break, giving the electron to chlorine, and this electron coming towards the space in between, while this electron also, then a bond will form here, breaking this bond. So the thing is, will be like this. A new bond will form between that space, in this space, right? CCl bond, and the Cl dot will produce. So the idea is this, Lamai. Right? I'll tell you a story. මම පොඩි කතාවක් කියන්න. මේ පොඩක් තීරුම් ගන්න. දැන් පොඩ්ඩක් නිකන් මොකද්ද වෙන්නේ කියලා තේරෙන්නේ නැහැ වගේ සිටුේෂන් එකක් තියෙන්නේ. මම චුටි කතාවක් කියන්න. හරි? ඒතර වැඩි වෙන තීරණයක්. හරි. මේවයි. මේක ඇත්ත කතාවක් හොඳයි. මේක වෙලා මේ මං ඉස්කෝලේ යන කාලේ වෙච්ච කතාවක්. එකෙට්ට ගැහුවට පස්සේ අදාළ නැහැ. ඉස්කෝලයක් පිටින් වන්දි ගෙවන්න ඕනේ ඒකට. අපේ එකට සද්ද දැම්මම. එහෙම සීන් එක තමයි මේ වලිය යන්නේ. කවුද ගැහුවේ කියන එක අදාළ නැහැ. අනිත් ඔක්කොම ගහන්න. ඒක දිගට යනවා. හරිද? මම තමයි කතාව. චේන්ම තමයි චේන් රියැක්ෂන්ස් වගේ තමයි කෙට් එක ගැහුවොත් අනිත් උන් ගහන්නේ අනිත් උන්ට ගහන්නේ. එහෙම කේස් එකක් තියෙනවා. හරි. මම ওই කතාව කිව්වේ ඔය ඇත්ත කතාව. හරි. දැන් උයි දැන් තියෙන්නේ ළම මේ නිකන් දැන්ටත් ඔය සමහර මිනිස්සු තියෙන්නේ අපේ කාට ගැහුව නිසා හැමෝටම ගහන්නේ. ඒක සාමාන්‍යයෙන් ඒ කාලේ තිබ්බ මේ ඉස්කෝල අතරත් තිබ්බා ඒක. හරි. මේකේ මම අහන්න කියන්න හදන්නේ මේ කේස් එක. මොකද්ද මේ? දැන් බලන්න මෙහෙම සීන් යන්නේ. So here you have a good compound, good hydrocarbon. හොඳ හයිඩ්‍රෝකාබන් එකක් ඉන්නවා. කිසි ප්‍රශ්නයක් නැහැ. හොඳට ඉන්න කෙනෙක් ඉන්නවා. ඒ ඇස්සේ මෙන්න මේ reactive unstable Cl dot එකක් ඉන්නවා. More reactive means those are unstable, not with octet ne, unstable. So what happens here? You have a good compound, good carbon containing compound, and that will be attacked by a unstable chlorine compound, chlorine species. Unstable chlorine species good carbon compound attack කරලා තියෙනවා. So that ultimately what happens? The chlorine guy gets some stability, while the stable guy gets some unstable nature. තොර ස්ටේබල් හිටපු හොඳට හිටපු එකාට අන්ස්ටේබල් එකක ඇටැක් ක්ලෝරින් කෙනෙක් ඇටැක් කරලා මොකද උනේ? අර හොඳට හිටපු කාබන් අන්ස්ටේබල් වුණා. ක්ලෝරින් ස්ටැබිලයිස් වුණා. ඊට පස්සේ මොකද වෙන්නේ? දැන් අන්ස්ටේබල් කාබන් මොකද කරන්නේ? එයා ස්ටැබිලයිස් වෙන එයා මොකද කරන්නේ? එයා කරන්නේ හොඳට ඉන්න ක්ලෝරින් කෙනෙක්ට ඇටැක් කරනවා. එහෙම තමයි. එකෙක් ගේම දුන්නම් ඒගොල්ලගේ පරම්පරාවටම මේකට විදවන්න වෙනවා තමයි. හරිද? එකෙක් තමයි ගේම කෝල් කරන්නේ. ඌ තමයි ගේම දෙන්නේ. හරි. ඒ වුණාට අන්ස්ටේබල් එක්කෙනා ඒකේ වාඩුව ගන්නෙ එයාගේ අනිත් එවුන්ගේ. හරි. So unstable carbon get that revenge from the stable chlorines. attack කරනවා එයා stabilize වෙනවා chlorine unstable වෙනවා. right. ඔහොක වැඩේ දිගටම යනවා. වැඩි ඉවරයක් වෙනකම් යනවා ඕක. හරි. So that is the first connection of the chlorine to your organic compound. ඊට පස්සේ මොකද වෙන්නේ? වැඩි ඉවර වෙන්නේ නැහැ. මේ ක්ලෝරින් මොකද කරන්නේ? ඒ ක්ලෝරින් මොකද කරන්නේ? එයා ආයසරයක් හොඳට ඉන්න කාබන්ට ඇටැක් කරනවා. වැඩි නවත්තන්නේ නැහැ. දිගටම යනවා. right? මෙන්න මෙයාටම ආයෙත් ඇටැක් කරනවා. හොඳට ඉන්න කාබන්ට ඇටැක්. හොඳට ඉන්නේ උන්ට හොඳට ඉන්න කාබන්ස්ලට unstable chlorinesලා ඇටැක් කරනවා. ඊට පස්සේ unstable වෙන කාබන් ගිහිල්ලා හොඳට ඉන්න chlorinesලා ඇටැක් කරනවා. ඕක තමයි දිගටම යන්නේ. now this one just write this one again. පොඩ්ඩක් ළම එයාම ලියමු by just rotating the bond. හරි. පොඩ්ඩක් rotate කරලා ලියනවා මම මෙහෙම. පොඩ්ඩක් මෙහෙම rotate කරනවා. rotate කරලා ලියනවා. the same compound. So that will be attacked by this dot. And the same procedure will repeated. මේ වැඩේම repeat වෙනවා. Same procedure will repeated. Right? These two will react to produce what? The carbon dot. Those two will react to produce the carbon dot and the HCl. Right now? So good carbon react with the chlorine dot to produce the carbon dot and the good chlorine. Right? So that the carbon dot will react with the good chlorine to give the good carbon and chlorine dot. ඇත්ත මාරුයි යන්නේ හරි. දැන් මේකම දායිසරයක්. Good carbon react with the dot chlorine to produce the dot carbon and good chlorine. හරි නේද? හරි. ඊට පස්සේ මොකද වෙන්නේ? This one good dot carbon will react with a good chlorine. It will attack to a good chlorine to produce the good carbon and dot chlorine. කොතනද වෙන්නේ? හොඳට ඉන්න එකව ඩොට් කරලා නරක වෙච්ච එක හොඳ වෙනවා. ඔක දිගටම යනවා ඉතින්. හරිද? අපි මේකේ electronic movements mark කරමු. To produce these two guys, you should have a dot here with the carbon so that one of the electrons should come towards that carbon. The other electron should come towards this position to form the bond, and this electron should also come towards that position to form this HCl bond. For this thing, to produce these products, one of the electrons from here should come towards this chlorine to produce a Cl dot. The other electron should come towards this space to produce the CCl bond. To produce the CCl bond, this other electron and this electron should come towards the space in between to produce the CCl bond. And this goes to produce the Cl dot. Right නේද? ඉතින් ඔහොම තමයි මේ වැඩේ දිගට යන්නේ. ඉතින් ඔහොම ක්ලෝරින් සහ හතර දෙනා වෙනකම්ම වැඩේ සෙට් වෙනවා. This is the connection of the second chlorine, right? So let's complete the stuff. The repeating trend, right? ඊට පස්සේ මේ දෙන්න ආයෙත් පටන් ගන්න ආයෙත් repeat එකගෙන යනවා. Step by step ගිහලා repeat. දැන් මෙයාව ආයෙත් මේ rotate කරලා ලියන්න. Right? The carbon hydrogen bonds are the ones which will break. And CCl bonds are the ones which will produce. That should be the things to happen, no? The carbon hydrogen bonds should break and CCl bonds should form, right? Okay? Right. Okay, let's continue the stuff to complete and to come up with the CCl4, right? These two things are the first two things, right? So you can write the mechanism lamai. Pirivalta liyanna. Liyadde me electronic movements very important, right? So these are half arrows which indicates one electron movements, right? Which indicate one electron movement, right? Half arrows එක electron එක movement එකක් represent කරන්නේ. So just complete the stuff. හැමතිස්සෙම අර කතාව ඔළුවේ තියාගන්න. හරි? Good carbon and dot chlorine gives you dot carbon and good chlorine. Then that dot carbon tries to stabilize by attacking to a good chlorine, which will come up with a good carbon and a dot chlorine. අර මේ එකක් මෙන්න මේ එක පෙයාර එකක් ඔලුවට දාගත්තා හරියට ඒකම තමයි දිගටම රිපීට් වෙන්නේ. මෙයා පොඩ බොන්ඩ් එක රොටේට් කරලා ගන්න හයිඩ්‍රජන් එක මොලිකියුලර් රොටේට් කරලා ගන්න. හරි just complete the stuff ළමයි කරන් යමුද මේ දෙක මුලින් ලියන්න ඊට පස්සේ මම මේ පැත්තෙන් ලියන ඊටු ටික right. I complete the stuff from here, right? Afterwards, make it complete කරලා මෙතන පැත්ත දෙන්න. Then what will happen? This was the ultimate stuff produced. Then those two guys will react, right? Like this. Just rotate the component, right? So this is the hydrogen, the bond to break. So the two chlorines are connected here. This is a compound. So that will react with the chlorine. So what should happen? Chlorine dot, right? So this guy will attract the hydrogen. This guy will attract the hydrogen, and this guy will come as a dot. This guy will come as a dot. So it is Cl, Cl, hydrogen, and this is dot, and this guy will attract the hydrogen, right? HCl. So to this thing to happen, the electronic movement should be like, there should be a bond form here. That means this electron should come towards that position, and one of these electrons should come towards that position. That is how the HCl bond is formed. And to produce the C dot, one of these electrons should come towards oxygen, carbon, sorry, come onto the carbon. Right now? Okay. So next stuff, right? So when this one, the so produced dot will attack to a good chlorine, Cl2. Right? To come up with good carbon and dot chlorine. For that to happen, right, to produce this dot, one of the electrons should come towards here, half arrows, one electron movement. To produce the bond between the C and Cl, the other electron should come towards here, and this electron should also come towards here. That is how the two electrons are to be produced. Two electrons are coming to this space to produce the CCl bond. Right now, that is how the third chlorine is connected to your carbon. Gradually, step by step, that thing will happen. Just complete with me now. Then what happens? This thing, just rotate that thing and right, because CCl bonds are not to be broken here. Only CH bonds will be broken, right? Those things will be substituted by the chlorines, right? So just rotate this thing and right. Now you have CCls, 3 CCls, right? Again, good species always reacting with a dot species. When it comes to propagation steps, always a dot is involved. Huh? When it comes to propagation steps, always a reactive dot is involved. Here or here, here or here, dot is also always involved. at the reactant site, and dot is also produced at the product side as well, right? This is what happens now. I can just write it here, right? To form that bond like that, this one of these electrons should come towards the space between, like this, and this electron should come towards to the on top of the carbon to form the C dot, right? So next one, right? So now you have things like this, some dot here, and then dot thing will attack to good chlorines, so that to produce the bonded final compound, the CCl4, and one of the chlorines will release there as a dot. So to produce these things, what should happen? This one of these electrons should come towards chlorine as a dot, and the other electron should come towards the space in between to produce this CCl bond. Right now? So these are your propagation steps. Altogether 8 steps are there. 8 propagation steps are there to completely come up with the CCl4. Right now? 8 steps are there. Make a complete, right? So this is all about the propagation steps, right? Now we have produced the CCl4. Shape නේ ලායි. හරි complete කරගන්නකො. ඔළුවට ගන්නලා හරි ලේසි වැඩක් තියෙන හරි එකක් හරි set කරගත්තා හරි. මුලින්ම initial steps තියෙනවා. So there the radicals are produced. Then propagation stage. When it comes to propagation steps, right? Total amount of radicals won't change, lavai. Net amount of radicals won't change. At this side, only one radical is there. At the other side as well, only one radical is there. Always one radical is maintained with both the sides. Right? Here only one radical is there out of 2 reactants. When it comes to products, only one radical is there. Radical number won't change. Here, with the initial stages, radical amounts increase. Amount of radicals increase when the reaction occurs. Amount of radicals won't change when the propagation steps occur. Right? That is what we need to gather from this thing. Those are the propagation steps, right? Altogether 8 propagation steps are there. Right now? So all the arrows are half arrows, because this is kind of a reaction involving radicals. These steps are actual radical steps, right? Involving radicals, 1 electron movements. So half arrows should be mentioned. And when writing these things, right, make sure you are starting the arrows, right, from places where the electrons are. You should start the arrows from places where the electrons are. See, always the arrow, the tail starts from a place with electrons. See? Okay? It's very important, na? I'll check your notes next day. Right? At the class, I'll check your notes. Right? So, carefully draw the arrows. That is the most important thing. They will give you marks. They will give you marks for the arrows, correctly indicating the arrows. Then the products. Arrows will be with greater allocation of marks, right? So, arrows should start always with a place where the electrons are. Right? See, all the arrows are started with a place with electrons. The arrow. Because the arrows are all about electronic movements. Electronic movement. This arrow is all about the electronic movement of this electron. This arrow is about the electronic movement of this electron coming from here to here. This arrow is about electronic movement of one of these electrons that came to here. Other electron came to here. Arrows are all about electronic movements. So carefully draw the arrows. Those arrows should always start from a place with electrons. Right? දැන් ඔය arrows හරියට අඳින්නෝද? දැන් මේ සමහර ළමයි මේ arrows අඳිද්දි මෙහෙම ලියනවා. මෙන්න මෙහෙම. ඔහි අඳිනවා මෙහෙම. වැරදියා. This is wrong. This is wrong. Why? Because you started the arrow from here. There you don't have electrons. Always start the arrow from a place with electrons. See? This is right. Arrows are electronic movements. This electron coming towards here to form the HCl bond. One of this electron coming towards here. Arrows indicates the electronic movements. Very important, na? දැන් මම උගල පොත් ටික ගේන්න ඕනේ මම චෙක් කරලා බලනවා හරි හරියට arrows ටික අඳින්න. ඊළඟ වීඩියෝ බලලා හරි අඳින්න ඕනේ. electrons තියෙන තැනකින්ම arrow එක පටන් ගන්න ඕනේ. arrow එක කියන්නේ electronic movement එකක්. හරි? මෙතන තිබ්බ electron එක මෙතනට ආවා. මෙතන තිබ්බ electron එක උත් මෙතනට ආවා. එහෙම වෙලෙ බොන්ඩ් එක හැදුවා. electrons දෙකකින් බොන්ඩ් එක දෙන්නේ. මෙතන තියෙන අනිත් electron එක මේක උඩට ගියා. It is what happens here. මෙතන electron එක. හරි? ඔය බිලි වලට ලියන්න හරි? shape ne? Hard. That is all about this mechanism, the propagation steps. Final, ultimate story, right? Andi batao. Let's come up with the third thing. අපි තුන්වෙනි එකත් පොඩ්ඩක් අදිමු. ඊටත් නෑ ඔය ගමන්නේ. හරි. විතර පොඩ්ඩක් දාමු නේද? Third one. Termination steps. Termination steps. I earlier said no. 3 steps are there. 3 types of steps are there. Termination steps. Right? So I'll write the termination steps, right? Termination steps means this line. When so produced radicals are to react with each other. So if two radicals are to react, right, such situations are considered as termination steps. Radicals then create karna apni you know termination steps kiya. So initial steps are actually producing radicals. Propagation steps, radical number won't change. Termination steps means consumption of radicals. Consumption of radicals. Initiation is producing radicals. Termination means consumption of radicals. When the radicals consume, the things will ultimately end. That is why it is referred to as a termination steps. Radicals are the driving force, no? Reactive centers. No? If the radicals end, then ultimately the thing will end. Termination steps. The radicals react to consume them. See? So we can write numbers of termination steps, right? Okay? I'll write few. I'll write few of those. This Cl dot can be reacted with another Cl dot to produce Cl2. There is one termination step. Some CH3 dot, this kind of CH3 dot can be reacted with a Cl dot produced from these steps, right? To produce the CH3Cl. No? So I'll write one here. I'm lack of space, right? So another CH3 dot will react with another CH3 dot. So react with another CH3 dot. Ions cancel off those radicals, producing CH3, CH3. Right? So radicals consume. You only have pull me tahu me wakare me CHCl2 dot. Kamu dia lihat CHCl2 dot reacting with any kind of Cl dot kind of thing to produce CHCl3. Like that. You can write numbers of termination steps. The major thing to concern here is the radical number will decrease when the reaction occurs, when step occurs. Consumption of radicals. Starting with 2 radicals, ending up with nothing. With all these termination steps, you see the same pattern. Starting with 2 radicals, ending up with nothing. Initiation is the other way around. Starting up with nothing, ending up with 2 radicals. Radical generation happens at the initiation step. Radical consumption happens at the termination step. In propagation steps, no net consumption, no net production. No net consumption, no net production of radicals when it comes to propagation steps. Right now, this is the whole mechanism of producing CCl4 starting from CH4. Whole mechanism, that means the diagram indicating all the bond breakings and bond forming with the use of curvy arrows which denote the electronic movements. Right? This is it. Total mechanism. So you can complete the stuff now. Just write these 2 things as well. Just 4, just 4, right? Just write. Naming as termination steps. Right now? Okay. Shape it. So you can copy this, right? When writing termination steps, it is not needed, right? Not needed to draw the curvy arrows. Not that essential, right? But with the propagation steps, it is essential to come up with the curvy arrows. Even in the initial step, you can write the curvy arrows, right? Curvy arrows means the kind of electronic movements. If you wish to add, you can write, right? Just these 2 electrons are coming towards here to form the Cl2 bond, right? This electron coming towards the space in between, and this electron as well to form the bond between the 2 Cls, that is Cl2. Right? Something will happen, right? No need to indicate for the termination steps, right? Even though, right? Okay, no? So any questions, Lord? No, any questions with you from the lesson we have learned so far? You can copy the chat box. No, all of them. Shape, ne? Okay. Right. That is done. Then, when looking at this mechanism, few important things are to be mentioned. Right? We need to note that very important things happen here, right? What are the important stuff we could observe with this mechanism? Let's write those things one by one, right? Let's write those things. The important things with this mechanism, right? The first thing I'll first discuss the important stuff here, and then we can write. The first thing, right? This is considered as a radical mechanism. So that you won't see the appearance of ions. In this mechanism. No ions involved in this mechanism. As a reactant or as a product in these steps, no involvement of ions. You won't see any ion involvement in all of these steps. මේක ස්ටෙප් එකත් අයන් එකක් ඉන්වෝල්ලා නැහැ. කොහොමවත් අයන්ස් නැහැ. ප්ලස් නෙගටිව්ස් නැහැ. because this is considered as a free radical reaction. Just radicals involved. No ions. No positive negative ions in this mechanism, throughout this mechanism. That is the first thing to mention. No ions involvement. Right? Second thing, දෙවනි වැදගත් කාරණය. When looking at these all these steps, the second most important thing. I'll write the note. I'll give you the note. Right? First, let's discuss. After that, we can write. Second thing. So you basically, when it comes to this reaction, total reaction, three types of elements are there. No? What are three types of elements? Carbons, hydrogens, and chlorines. In all this mechanism, right? You see only three types of elements: carbons, hydrogens, and chlorines. But when it comes to radicals, only the carbons and chlorines are bearing these radicals. Only the carbons and chlorines bear these radicals. Not hydrogens. You see, in this mechanism, you clearly see chlorine radicals appear. Almost everywhere the chlorine radicals are appearing. Each and every step you can see a chlorine radical appears as a reactant or a product throughout the mechanism. Throughout the mechanism you see the carbon radicals appear. C dots. Even as products, even as reactants, carbon radicals will appear throughout these propagation steps. See? But you won't see the appearance of H dot, the hydrogen radical. That is not there. That is not here. It's very important to note that. No H dot radical throughout the mechanism. Lama H dot means it's a very, very unstable species. H dot, just one electron in the 1s subshell, just hydrogen, just one electron in the first energy level. The first energy level is not completed. The closest energy level to your nucleus is having a vacant site, not completed. Right? That is a very, very unstable situation. The closest energy level means the energy level with the greatest effective nuclear charge. That is with a space. That won't last for long. Quickly, from anywhere else, somewhere else, that space will be filled by attracting an electron. Right? So that won't last. H dot won't last. So highly unstable, so that can't be seen with this mechanism. It won't be produced. So as it is not going to be produced, it can't be reacted. If it is not going to produce, it is not appearing, it can't get involved in a reaction as well. So no H dot radical throughout the mechanism. That is very important to note that. Right? Those are the major 2 points. Then first write those two things. First, just write those two things. At the page number 15, you have some space. Put space at page number 15. Right? Note kill dala, red color again, note kill dala. Just write this thing. Right? Just write. Just put a note and just write then. First point. Just write with me, right? First point. Right? Do I need to write here? No, just write. Just write. First point. This is a come to red color and write. Free radical substitution free radical substitution. Free radical substitution. Free radical substitution. Come to the normal color. Mechanism. Mechanism. This is a free radical substitution mechanism. So again come to the red color. Come to the red color and write. No involvement of ions. No involvement of ions. No involvement of ions throughout the mechanism. Throughout the mechanism. No involvement of ions throughout the mechanism. No involvement of ions throughout the mechanism. Right now? Okay. Next point. Next point. Second point. With the red color, just continue. H dot. You see? H dot. Within brackets, hydrogen radical. Hydrogen radical. Close the brackets. H dot. Within brackets, hydrogen radical. Won't appear. Won't appear. Won't appear. Won't appear. Come to the normal color. Come to the normal color. In this mechanism. In this mechanism. Won't appear in this mechanism. As H dot is H dot within brackets hydrogen radical. As H dot hydrogen radical close brackets is highly unstable and so won't exist. As H dot within brackets hydrogen radical close brackets is highly unstable and won't exist. And won't exist. Highly unstable and won't exist. We have a question there. Mr. Yes. Cannot the termination steps occur during propagation? Yes, I'll discuss that. Right? Okay. So second point is H dot won't appear in this mechanism as H dot is highly unstable and so won't exist. Right? Okay. Ne? Hari. Mushraf is asking a question, right? The question is, cannot the termination steps occur during propagation? Cannot the termination steps occur during propagation? Right? You can during propagation termination steps in the bad. Right? Okay. So it could happen. It could happen. මේක ප්‍රැක්ටිකලි ගත්තා පස්සේ මෙහෙම සීන් එකක් වෙන්නේ. ප්‍රැක්ටිකල් සිනාරියෝ එක. දැන් ඔයාගේ රියැක්ෂන් මික්ස් එකේ හරි? ඔයාගේ රියැක්ෂන් මික්ස් එකේ CH4 ලා එක්කෙනයි නෙමෙයි ඉන්නේ. Your reaction mixture contains Avogadro's number of CH4 molecules. Your reaction mixture contains Avogadro's number of CH4 molecules. Right? So 102 may start like this. 1000 will be started like this. Right? At the beginning, thousands of reactions will start like this. And with some time, another thousands will start the reaction. You can learn මේ හැමෝම එකම වෙලාවේ reaction start කරන්නේ නැහැ. හරි? මෙතන reaction change හුඟක් යනවා. CH4 එක්කෙනෙක්ගෙන් යන change එක තමයි මම මේ ලියලා තියෙන්නේ. CH4 එක්කෙනෙක්ගෙන් involve ලා යන complete chain එක තමයි මම මේ ලියලා තියෙන්නේ. මේ වගේ CH4 ලා හරි Avogadro ගානක් reaction chains වලට involve වෙනවා. මේ එක්කෙනෙක්ගේ chain එක තමයි මේ ලියලා තියෙන්නේ. ඒත් එක්කෙනෙක් යනකොට එක්කෙනෙක් යන අතරතුර තව එක්කෙනෙක්ගේ ටර්මිනේෂන් එකක් වෙන්න පුළුවන්. වෙන CH4 ගේ කෙනෙක්ගේ පටන් ගත්ත ටර්මිනේෂන් එකක් වෙන වෙලාවක එක CH4 කෙනෙක්ගේ ස්ටාර්ට් එක වෙන්න පුළුවන්. මේ ප්‍රොපගේෂන් එක යන වෙලාවක වෙන CH4 මොලිකියුල් එක ටර්මිනේෂන් එකක් වෙගෙන යන්න පුළුවන්. වෙන්න පුළුවන්. ටර්මිනේෂන් ස්ටෙප්ස් වෙන ගමන්ම ප්‍රොපගේෂන් ස්ටෙප්ස් යන්න පුළුවන්. හැබැයි කොහොම හරි එක CH4 කෙනෙක්ගේ ටර්මිනේෂන් ස්ටෙප් එකක් ගියොත් එතනින් එයාගේ චේන් එක ඉවර වෙනවා. දැන් මේ CH4 ගේ චේන් එක මෙහෙම යනකොට හරි මේ CH4 චේන් එක මේ හරියද වගේ හරි මේ හරියද වගේ මෙයා ඇවිල්ලා වෙන CH4 කෙනෙක්ගේ මේ වගේ එකක සෙට් වුණොත් මෙයාගේ වැඩේ මෙතනින් ඉවර වෙනවා. නැත්නම් මේ CH4 චේන් එක මෙහෙම යන ගමන් හරි මෙයාගෙන් හැදිච්ච Cl කෙනෙක්ගෙන් ඇවිල්ලා කනෙක්ට් වුණොත් එයාගේ චේන් එක එතනින් ඉවර වෙනවා. ආයෙත් මේ ටික යන්නේ නැහැ. හරිද? හැබැයි එහෙම කියලා ප්‍රොසෙස් එක නවතින්නේ නැහැ. ඇයි තව CH4 වල ඉන්නවා. තව CH4 වලින් ස්ටාර්ට් කරපු චේන්ස් තියෙනවා. ඒ චේන්ස් ටික යන නිසා වැඩේ කොහොමද ඉස්සරහට යනවා. So termination එක ඔක්කොම එකට යන වෙමින් තමයි වැඩේ ඉස්සරහට යනවා. right? shape නේ. හරි. chains ගන්න වැඩක් නේ. right. Let's write the third stuff. තුන්වෙනි එකත් ලියමුද මෙහෙම. third point එක ලියන්න මම ඊගොම discuss කරන්න right? describe කරන්න. third point just write like this. Under special notes right? third point. Propagation steps contribute more propagation steps contribute to more propagation steps contribute to more yield propagation steps contribute to more yield propagation steps contribute to more yield compared to termination steps compared to termination steps propagation steps contribute to more yield compared to termination steps right compared to termination steps propagation steps contribute to more yield compared to termination steps right ඒ මොකද්ද වන්නේ කිව්වේ හරි දැන් බලන්න ළමයි හරිද දැන් to produce the CHCl3 to produce the CHCl3 let's take this one to produce the CHCl3 you can use a propagation step to produce this one sorry to produce CH3Cl to produce CH3Cl you can use a propagation step as well as a termination step with the termination steps also we can produce CH3Cl with the propagation steps also we can produce CH3Cl the propagation steps වලින් CH3Cl දාන්න පුළුවන් termination steps වලින් දාන්න පුළුවන් CH3Cl නෙමෙයි ළමයි ඕන එකක් පුළුවන් CCl4 හදන්නත් පුළුවන් CCl4 අපිට හදන්න පුළුවන් propagation steps වලින් ගිහිලා CCl4 හදන්නත් පුළුවන් termination එකේ පුළුවන් if CCl3 dot to react with the Cl dot CCl3 dot react with the Cl dot will produce a CCl4 for all the chlorinated hydrocarbons can be produced by propagation steps as well as termination steps but we say the propagation steps contribute to more yield contribute more to the yield we say the propagation steps contribute more to the yield compared to the termination steps the logic is this lamai the logic is this when a termination step to occur when a termination step to occur from that step the reaction stops from that step the reaction stops if a termination step to occur after that step the radicals will consume and the reaction stop but when you have to consider a propagation step even after producing the yield product a radical will be there. A radical will be there. So that this radical can contribute to form another CHCl3 from another CH3 molecule. This radical can contribute to produce another CH3Cl from a new CH4 molecule. මං කියන්නේ පැහැදිලි දන්නේ. propagation step එකකින් ළමයි CH3Cl හැදුනාට පස්සේ ඒකෙන් Cl dot කෙනෙකුත් හැදෙනවානේ. ඒ Cl dot පුළුවන් තව හොඳට තියෙන CH4 කෙනෙක්ට attack කරලා එයාගෙනු CH3Cl හදන්න. ඒතකොට මේ step එක නිසා CH3Cl හැදෙනවා වගේම එයාගේ by-product එකෙනුත් ආයිසරයක් CH3Cl කෙනෙක්ව හදාගන්න පුළුවන් හොඳට තියෙන CH4 කෙනෙක්ට attack කරවලා ආයිත් මේ වගේ. So that means the propagation steps contribute more to the yield compared to termination steps. මේ විදිහට ළමයි CH3Cl හැදුවොත් එයා හැදුවම තමයි ඒ CH3Cl එක විතරමයි හැදෙන්නේ. මේ step එක contribution එකේ. හැබැයි මේ විදිහට ඔයා CH3Cl කෙනෙක් හැදුවොත් ඒකෙන් හම්බ වෙන by product එකෙනුත් ඔයාට පුළුවන් තව හොඳට ගින්න react කරපු නැති CH4 කෙනෙක්ට react කරවලා ආයෙත් තව CH3Cl කෙනෙක් හදාගන්න පුළුවන්. පේනවද? එහෙම නැත්නම් අර කොහේ හරි තියෙන තව එකෙක්ගේ CH3 dot එකට attack කරලා ඒත් පුළුවන් CH3Cl කෙනෙක්ට හදාගන්න ආයෙසරයක්. මෙයාට අමතරව තව කෙනෙක්ව හදන්න මේකෙන් contribution එකක් ගන්න පුළුවන්. So propagation steps contribute more to the yield than the termination steps. හරි අය පොඩි ඕක දාගමුද පොඩි මේ නෝට් එක. example එක. පොඩ්ඩක් මේක වකනවා ළමයි හරි. example එක දාගන්න. අපි කතා කරපු එකම example එක දාගමු. Just write this thing as the example. Example: to produce CH3Cl, right? Following steps can be used. Steps දෙයක් use කරන්න පුළුවන්. We can use this step to produce the CH3Cl, right? Actually, which is the propagation step. Or we can use this step to produce the CH3Cl. Actually, it is a termination step. හරි ඔය ස්ටෙප් දෙක මාඩ යූස් කරන්න පුළුවන්. Right? This is referred to as a propagation step. This is referred to as a termination. I'll mark these two things as 1 and 2. Two reactions. Right? Just write this thing now. Mathematical make. Then you can write here 1 is contributing more to the yield compared to 2. 1 is more contributing to the yield compared to 2. Alright, let's complete this one. Alright. Those are special notes, right? You can box this stuff. You can box that whole thing, the special note. This is a propagation step. This is a termination step, right? So propagation steps contribute more to the yield. Contribute to the I'll write the contribute to the CH3Cl yield compared to the two. Right now. Right. ළමයි මේ අපි වැඩි නවත්තන්න කලින් පොඩ්ඩක් question එකක් දෙකක් බලමුද next page එකේ තියෙන page number 16 වල තියෙන මම පොඩි idea එකක් වඩ දෙන්න හරි පොඩි idea first two questions වගේ කරලා දෙන්න හරි first three we'll do the first three quickly. I'll discuss you can do it at home as well. I'll quickly go through first three questions to give you some idea how the questions are to be asked, right? How the questions are going to be asked, right? Just go to the first question. See what it says. When it comes to first question, right? When it comes to first question, right? See what they are asking at the page number 16, right? Page 16. Question 1. So they have given these things, these choices. Second choice is what? CH3 dot Cl dot CH3Cl. The choice. These are the multiple choices, right? Of the question. Cl2 CH3Cl plus Cl dot. Then fourth choice, CH4 giving you the CH3 dot NH dot. The fifth choice, CH4 plus Cl dot giving you CH3 dot plus HCl. Hari. මොකක්ද අහන question එක? The question is this. Which one of the following steps does not take place? Which does not take place? That is your question. මොකද්ද වෙන්නේ නැත්te reaction mechanism? Which of the following steps does not take place during the free radical reaction of Cl2 with methane? If such a thing is asked, just look for ions or for H dot radicals. Just look for ions or H dot radicals. Ion won't produce. This is a free radical reaction. No ion involvement. H dot won't produce. So H dot can't appear. H dot can't appear because H dot is highly unstable. So if such a step is given, that is the step which is not going to occur. That is the answer. See, you clearly see here the H dot is appearing. So the answer is 4. Throughout the mechanism, H dot won't appear. That is the idea. So the answer is 4. See, very easy to come up with the answer if you know the basic stuff there. Right, no? Okay. So let's discuss about the second one. Right? Let's discuss about the second question. Okay. ටක් ගාලා questions දෙක තුනක් මම කතා කරන ඕලත් එක්ක මේ වෙලාවත් ඉවරලා තින්නලා නේද? Just give me 2 minutes, right? 2-3 minutes to discuss few questions, right? Because then you know how to what things are to be studied, what things to be considered more when you are doing studying, right? See, second one. The second question පොඩි වෙනසක් හදා ගන්න ඕනේ. It is said like this: which of the following most correctly depicts a propagation step? අර එක වැදිලා නැහැ. Just correct that thing. Which of the following most correctly depicts a propagation step? Propagation step in the reaction of chlorine. Right? We are looking for propagation. Right? Propagation step. This is the propagation step they are asking, right? The first thing. What is this? This is the initial step. ළමයි, propagation step means what? Right? Think of propagation steps, right? So just come up with the answer, good answer. Then I'll explain. First, try to come up with the answer, good answer. These are the things they have given. Right, sorry. So these are the major answers. Right. Some 5 is also there. මම මේක ගැන කතා කරලා අපි වැඩි ඉවර කරමු නේද? අපි ආන්සර් එක ගන්නගෙන මේ ළමයි වැඩි අනිත් ඒවා වැරදියි කියලා හොයාගන්න එකත් වැදගත්. හරි. Right. බලන්න. මොකද්ද propagation step එක? හරි. පළවෙනි එක propagation step means the number of radicals should not change. The net amount of radicals should not change. The number of radicals at the reactant side should be equal to the product side. That is how a propagation step occurs, right? So this is not the case. This is initial step. Propagation steps, number of radicals won't change during the step. That is what happens with the propagation steps. Right, see. Next one. Is this the one? Is this the one? So do you have, yeah, not good, no? Yes, is this one? No. Actually, these electronic transitions are not good, no? These electronic transitions are not good, right? So, first of all, you need to come up with some electronic transition like this. For homolytic cleavage, ne? This electronic transition should be right mentioned. And with this thing, actually they are trying to create a H dot. If the electron are to be come onto the hydrogen like this, if the electron is to come to the hydrogen like this, it will create a H dot. It is not mentioned as well, right? And it is not good, no? So that is a very wrong step. If you are to put the electron transition like this, if the electron transition occurs like this, I just write like this, then it will give the H dot. That can't happen. That can't happen. And then this is the answer. This is the answer. This is how the hydrogens are removed from the carbons, not like this. In these propagation steps, the hydrogens are removed like this, not like this. If you remove the hydrogen like this, it will produce the H dot. That can't occur. The hydrogens are removed like this, producing HCl. The electron of this bond, which belongs to hydrogen, won't come on top of the hydrogen. It comes to the space in between the hydrogen and the chlorine to produce the HCl. That is how the hydrogens are removed in this mechanism. Quickly, closely look at that thing. මේ ඉලෙක්ට්‍රෝන එක හයිඩ්‍රජන් වලට යන්නේ නැහැ. ඒක H dot හදන්න that is not good. මේ හයිඩ්‍රජන් අයින් වෙන්නේ කොහමද? ඉලෙක්ට්‍රෝන එක දෙන්නගේ ස්පේස් එක ගෙනියලා by producing the HCl. So that is why this is wrong and this is the correct answer. So this is kind of propagation step. The net number of dots won't change here. හරි? මේක ගත්තොත් පොඩ්ඩක් මේකත් අවුලක් නැහැ වගේනේ. ඒකත් which of the following most correctly depicts the preparation step in the reaction of Cl2. දැන් ඔයාගේ step එකෙත් third එකෙත් අවුලක් නැහැ වගේනේ. third step එකත් අවුල් උත්තරේ ගන්න පුළුවන්. third is okay. fourth එකනේ. fourth එකේ අවුලක් තියෙනවද? You won't see a problem with the fourth thing as well, no? Yeah, fourth එකත් අපිට ගන්න පුළුවන් නේ. fourth එකේ ප්‍රශ්නයක් නැහැ. This is also happens, no? එකත් සාමාන්‍යයෙන් වෙන ප්‍රතික්‍රියාවක් reaction is okay. fifth one එක මොකද අවුල? fifth one එකේ අවුල මොකද ළමයි? What is the wrong? What is the problem here? We have problem here. At the beginning you don't have a reactive compound. You don't have a dot here. You don't have a reactive compound here. So this thing won't happen. This won't happen. As no radical at reactant side. No reactive atom to start up with. නේ අර unstable එකක හිටියොත් තමයි attack කරන්න හොඳ එක්කෙනාට. But here you don't have unstable guy. No reactive guy to start the step. So this won't occur. That won't occur. So these are two acceptable answers there. හරිද? ඔය answers දෙක අපිට පිළිගන්න පුළුවන්. Let's wind up at this stage. හරි මෙතනින් අපි නවතිමු. right මේ ඉතුරු questions එක කරන්න ළමයි. ඉතුරු ටිකත් කරන්න. අර fourth question එකේ පොඩි error එකක් තියෙනවා. අපි ඒක class එකේ හදන්න. මම දාන්න මේ වාගේ group එකට. right නේ? එහෙනම් අපි අදට මෙතනින් නවතිමු. මේ questions තුනක් තියෙනවා. අපිට group එකට දාන්න. right නේ? So we'll stop at this stage. Goodbye then. See you next week.